Hello everyone, welcome to my YouTube channel. I am Zui, and before we continue, I would like to request you to subscribe to my YouTube channel. If you are watching this for the first time, kindly subscribe and like my videos, and also share it out to your people, to your colleagues, to your folks. I will really appreciate, please. Thank you. Now we are going to look at how to draw curve of intersection for two solids that are intersecting. A question that we are handling here today is a vertical square prism of height 65 millimeters and of side base 40 millimeters with faces equally inclined to the vertical plane is fully intersected by a cylindrical solid of diameter 30 millimeters and length 65 millimeters. The cylindrical solid bisects the vertical square prism horizontally and perpendicularly. The two axes for both the solids are in the same plane and parallel to the vertical plane. Draw the plan and the front elevation showing the curve of intersection or curves of intersections. Now, how do we go about this? Now, first, we need to fulfill three conditions. The first condition is the vertical square prism is being intersected perpendicularly by a cylindrical solid, and therefore the lines at the axis should bisect and at right angles. Second condition is that the faces of the square prism, the base, the square base, okay, we are talking of the base is of square and the faces are inclined to the vertical plane. They're not supposed to be perpendicular or parallel, but instead they should be inclined. So we shall see how the faces will be inclined. Those are the two main conditions we should fulfill. And maybe the third one, the axes of the two solids that are intersecting are all in the same plane. So those are the three main conditions that we have to fulfill, even as we shall be drawing whatever we have to draw to show the relevant information. So let's proceed. First, we are going to start with the plan, and as we've heard, the plan is it's going to include the two solids intersecting, and the plan should also include the square base, which is going to be inclined, whose faces are going to be inclined to the vertical plane. So how do you draw this? Now first, we shall draw our horizontal baseline. I'm assuming this is going to be my baseline here. I'll draw a straight line. It can be a center line. I talk of a center line. This center line here is going to act as a baseline where we shall, okay, we can have first of all the baseline. Let me draw the baseline because we need to start a square at the corner. So let's use this one as our baseline. Now first we shall get to point out, like, this point is where we shall draw our square prism, the base. So first we are going to put our set square, our 45-degree set square, in such a manner so that it lies on top of this straight edge. So we shall draw this line, and then again we rotate the set square and draw this other line. These lines are 45 degrees to the base, so they are inclined to whatever we are calling the vertical plane. So how much do they measure? We are going to measure 40 millimeter. Square base 40 millimeter. Just come and cut here and also cut here, and we complete the base. So we get to draw and complete the base. This is a square base, and as you can see, two faces are going to be inclined. Like for example, this face and this face are inclined to the plane. If let's say we are going to have a plane here, so this particular plane, this face and this face are inclined to this plane, and also this face and this face are inclined. We are going to have our line there. So let's draw our plane. We can have our plane here. This plane will enable us draw the front elevation and also the end elevation. So this is our plane. And then once we have it that way, we shall come up with the front elevation. We just project lines from the base and we come up with the front elevation. So here we go. So we shall have this. Then we also bring this upwards. So that is our front. We can measure 65 millimeter as the height. So let's measure 65 as our height. That is our height. There it is. So we can complete. So this is just part of the front elevation, which is incomplete because at the end we need the curves of intersection appearing on it. And this is the plan, which is also incomplete because we also need to know where the intersecting cylindrical solid is going to cut through, because it will also appear in our plan. So for us to draw whatever I've just mentioned, it means we need our end elevation. Like we observe this object from this other side. What do you see? We need to see something on the end elevation. Now out of this end elevation is when we shall do the projections back to the plan and to the front elevation, and we shall be able to locate the curves of intersection. So let's just project from here and we come up with the end elevation. We want to have to see, what do we see if we want the end elevation to appear on this side? We are going to project on this side, the right hand side. Now next we are going also to project our plan. Just project everything, because once we have projected, we shall be able to know where the end elevation will be. So this is the projection from the plan. There it goes. Of course, we also did projection here. So next, we shall just locate a point where the projection lines from the plan will turn upwards to give us the end elevation. In this case, we use a 45-degree line just somewhere here, because you don't put it near to the front elevation, because a front elevation needs to have some extension of the intersecting solid. So we just put somewhere, but not so much close to the front elevation. So we are going to have a 45-degree line cutting through the base somewhere here. It goes the other side. So let's just continue drawing that line. So once it goes downwards that way, it has also to move so that these lines from the front, the plan will meet that line. Once they meet this line, they will have to change the direction to move upwards, because they are projection lines, and once they move upwards, they give us whatever we are calling as the end elevation. Now Like here, they are meeting here. So once we reach there, we can draw that line to move to the other direction. It moves upwards. So there it goes. It has to move upwards. Then also once it reaches here, it moves upwards. It moves upwards. So you can extend this. We want this line to be extended upwards. So once they move upwards, they give us part of the end elevation. You can also extend our center line because it's important for us to include it on our end elevation. The center line also, it has to move. How do you draw a center line? You just have long and short dashes. So once the center line meets that line, it also have to change the direction. It has to change the direction so that it moves upwards as well, just like the other projection lines. So there it goes. Once it goes there, we need to know where the cylindrical shaped solid is going to appear on our vertical square prism. It is actually at the middle point, and therefore we need to determine the center point where the circle will be drawn on this end elevation. How do we get it? It means, because the question is the cylindrical solid is bisecting the height. If it's bisecting, it means now we determine the midpoint. How do you get the midpoint? We can bisect or we just measure, because our height was 65, and in this case we can do the bisection so that we just get the middle value. Let me just do the bisection so we can have, let me reduce. I want to determine the middle point where the center line will pass through. So at that point we expect a straight line, which is a center line. So there we are, we have the center point. This is our center point. Now we need to know what is the radius. The radius of that cylindrical solid is 15, because our diameter was 30. So we just get to measure our 15 and we draw our circle. This is my 15. Just come with it here and draw a circle. This is the end elevation, part of the end elevation. Now we can divide the circle into 8 equal parts, and this one we can use a 45-degree set square. Just put a straight edge here, put our set square on top, and draw lines passing through the center. That is one. We move on the other side, we draw this other line again. So there we are. We can number as 1, 2, 3, 4, 5, 6, 7, 8 parts. Now once we have named, it means we also need to project those points back to the plan and through the front elevation. How do you go about this? We just draw these straight lines to pass through so that they all come and meet our plan. So this is 1. We move to the next. Next is 6 and 8. Let them just move and cut through the plan and pass, because the solid is intersecting fully, so it will have to project on the left hand side as well. So these lines, the extension on this line on this side is important because they will be expected to be drawn as well. Now next is 2 and 4. And lastly but not least is 3. So once we are done this, we can also do the same on the plan. We just draw the vertical lines to meet the plan. So we start with the first one. This is 1. Next is 2 and 4. Next is 4 and 6. Lastly is 5. So once they meet the plan, this 45-degree line, you draw so that they come and pass through. Really passing through? Yes, pass through the plan. We can bring this. So the first one comes, hits it here. Once it hits there, it passes through to the other side, and the next one is here. And it goes the other side. So we can move with them and number. This one is 5. This one is 6, in that order. They also move the other side. Now next, we need to ask ourselves, how long is an intersecting cylinder? Now the question was, a square prism of height 65 was going to be bisected by a cylindrical solid of length 65 millimeters. So we need to know half of 65 is 32.5. So we just measure that 2.5, and from the center of the vertical that 2.5, that is 3, that 2.5. Then we just come and that 2.5. At the center, and we cut on right hand side, on left hand side, and on right hand side to get how far the cylinder goes through. So now once we have that, we can draw the verticals. We can draw the verticals here. up to that point. So there it goes. Now once we have this, we shall get now to number. This is 7, this is 8 and 6, and this is 1 and 5, and this is 2 and 4, and this is 3. Okay, same applies to this other side. We are having 7, 6 and 8 in that order. So this is 7, this is 8 and 6, and this is 1 and 5, this is 2 and 4, and lastly this is 3. Now again we draw so that we move, we bring them downwards to the plan. We project them back to the plan. My drawing here was not so much accurate. I'm using a pen for clarity, but it's good with the appropriate pencils so that if anything goes wrong you can easily erase. With this one of mine I cannot erase because one, I've used a pen and a pen cannot be erased easily. So we can bring this other side again. So if you do your own drawings, ensure you do such that you are going to use the right pencils. I'm repeating. And if you use the right pencils, if you mess up anything, you can still do the correction. So now this one is 1, we bring 1, and this is 2 and 8, 2 and 8, and this is 3 and 7, 3 and 7, and this is 4 and 6. Just bring 4 and 6, 4 and 6, and lastly this is 5. So how do we establish the curves of intersection? On our front elevation, we are just going to move with those points. Like number 1, this is 1, and now we draw straight lines moving up to meet the front elevation from our plan, and this is how we go about this. So first we shall move this, the center line has, this line has moved, we come and move this. Then we come and move this. Same applies to the left hand side. We just do the same thing. It's a replica of what we have done on this other right hand side. So we just bring them. Now next we are going to locate those points. So the first one is number 1. So here is number 1. Next is 2 and 8. This is 2, 2 and 8. This is 8. This is 2, and lastly is 3 and 7. So you come with 3 and 7. It's 3 and 7. This is 7, and this is 3. On the other side again, this is 5. We come. So this is let's just do the same thing with 1 so that we don't forget. This is 1. So we come and look for 1. 1 is here. Next is 2 and 8. This is 2, 2 and 8. This is 8, and this is 2. And next is 3 and 7. 3 and 7. This is 7, and this is 3. So we are going to draw curves passing through those points we've just pointed out. This is how we draw curves. The curve should pass through these points. It should also pass through these other points on this left hand side. So that's how I've drawn those curves, so we can proceed by including all the necessary lines. include all the necessary lines. So these are the lines we need to see on the front. Now this curve and this one are what we're referring to as curves of intersection. So let's draw the plan. For the plan, this one is visible. The ones I'm drawing are visible, just the way they are. And then we can have this. But now, as it passes through, it's going to be hidden. So we draw it as a hidden detail. Then again, so we draw it as a hidden detail. So this is all that we needed to draw for this particular question. I would encourage you to use the right pencils for accuracy and also precision and neatness as well. Don't try using a pen. This is just for clarity. Enjoy your time.